Hello, this is SHSAT Mathematics Lesson 8. In this lesson, we will learn about identifying rational numbers and irrational numbers, conversion between recurring decimal numbers and fractions, calculation with absolute values, PEMDAS, sequence, calculation involving a number line. In this set A, which number is not a rational number? So let's go over a definition of a rational number. A rational number can be defined as any number which can be represented in the form of p over q, where p and q are integers and q is not equal to 0. The following are examples of rational numbers. Integers, for example, 5, fractions, example 3 over 5, mixed numbers, 3 over 5, repeating decimals, 6.32, that goes on and on and on. Terminating decimals, example 6.2. Perfect squares, for example, square root of 16, which would be equal to plus 4 or negative 4. So in this set, we have 5, 3 over 4. All of this were included here as examples of rational numbers. The only one that is not is radical 3, because it is not a perfect square inside. You cannot bring it out as a whole. So our answer is radical 3. In the set B, which number is not an irrational number? So an irrational number can be defined as any number which cannot be represented in the form of PQ, where P and Q are integers and Q is not equal to 0. So this is basically the opposite of a rational number, which we just went over. So it would include square roots. The square roots of non-perfect squares are irrational. So square roots, for example, radical 5, they're not a perfect square number inside. All of this would be included as an irrational number. Cube roots, where it's a non-perfect cube. Example, radical cube of 5. Higher roots of non-perfect higher numbers are also irrational. For example, fourth radical of 5, and pi, which is a mathematical constant, which would be 3.4, and it would go on and on. The mathematical constant e, 2.71828, is an irrational number. So in this set, which is not an irrational number, so radical 5 is an irrational number. This is the irrational number. This is also an irrational number. The only one that isn't is radical 9, because 9 is a perfect square number, and it would come out as a whole number 3. And pi is, of course, also an irrational number. So radical 9 is our answer. Show that radical 8 squared plus 9 squared is not a rational number. Between which of the consecutive positive integers is radical 8 squared plus 9 squared? So if you go over this expression, radical 8 squared plus 9 squared, in order to simplify it, you want to play out these exponents. So 8 squared is 64, 9 squared is 81. If you add that, you get 145. And 145 is not a perfect square number, therefore it is not a rational number. We know that 12 squared equals 144, and 12 is equal to radical 144. And the same thing for 13 squared is 169, and 13 is equal to radical 169. So we want to know between which two consecutive positive integers is this number. So since we got that as radical 145, we know that it would be in between 12 and 13, because radical 144 is what gives you 12, and 169 gives you 13. And 145 is a little bit bigger than this, so it would be in between 12 and 13. Take a moment and pause the video and practice this problem. This problem asks, make a set B with all rational numbers and set C with all irrational numbers from set A. So I'm going to write set B set C. And one by one, look at all the numbers from set A and see which is irrational, which is irrational. Radical 5 is an irrational number because it is not a perfect square inside. 25 is a whole number, so it's an integer. 1 over radical 2 is an irrational number since 2 is not a perfect square. 2.5 is a decimal, so it's a rational number. 0.666 is a repeating decimal, so it is also an rational number. 3 radical 5 is an irrational number since 5 is not a perfect square. Cube root of 27 is a rational number since 27 is a perfect cube. Radical 9 is also a rational number because 3 times 3 gives you 9, so it's a perfect number. 5 over 8 is a fraction, so it is a rational number. E is a constant, so it's irrational. 0 is a integer. 1 is also an integer. Pi is a constant number. 1 over 3 over 4 is a mixed fraction, so it's rational. And 3 radical 36 is irrational because 36 is a perfect square number, not a perfect cube number. So this is the set you should have. 0.3 times 0.3 repeating decimal. How do you do that? So it's simple. So you simply just multiply as you would a regular decimal. So 0.3 times 0.333, and you just multiply as it is, but just know it's a repeating result because it's being multiplied by the repeating number. How do you convert 0.6, a repeating number, into a fraction? So what you do is give 0.6 as a value of x, and then you multiply x by 10, and that makes 0.66 into 6.666. And when you subtract x from 10x, you can subtract 0.666 from 6.666, and that will get rid of the repeating decimal, so you will remain with just 6. And now you have 10x minus x, which is 9x, and you can divide 9 from both sides, and you have x equals 6 over 9, and that gives you 2 over 3, which is a fraction. How do you convert 2.35 into a fraction? So you give the x value of 2.3535, and then you multiply now with 100, and now you have 235, and by subtracting by 1x, and you do also subtracting by 2.35, 35, and that will give you 233, and you have 99x equals 233, and if you divide by 99 from both sides, you can simplify it and you get 235 over 99. So that's how you would make it into a fraction. So now convert to a single proper fraction. So you want to make this into a proper fraction. So what you can do is start with the top, give x a value of 0.05555, 10x as 0.555, so you just move the decimal to the right once. And for 100x, you make it into 5.555. And you can do 100x minus 10x, and that would be 5.555 minus 0.555, and you'll get rid of the decimal, the repeating decimal, and now you have 5, and 90, x equals to 5. So you have x equals now 5 over 90, because if you divide by 90 from both sides, you get 1 over 18. And now you want to do the same thing for the bottom, which is y equals 0.2777. You can do the same thing as we did with the x, so multiply with the 10, that becomes 2.777. Multiply y by 100, you get 27.777. And you subtract 100y minus 10y, 27.777 minus 2.777. And so you would have now 27 minus 2, that would give us 25. So you have 90y equals to 25. So now you have y equals to 25 over 90, that gives you 5 over 18. And now you can plug in the change fractions, and now you have a fraction over a fraction, so you would do KCF, which is the way you would divide fractions. So you did KCF, and now you have 1 over 18 times 18 over 5 equals 1 over 5. Take a moment and pause this video and try this question to see if you can get that answer. So you would start this question off by first subtracting the numbers. Even though they're repeating, you can still subtract them. It will just be like the result will also be repeating. Subtract it, you would still get repeating number. So you have 2.2424. So what you can do, and you can put this as a value of a variable, so you can make x into 2.2424 repeating. And then what you can do, you can multiply both by 100 to get a variable of 100x. We have 24.24 continuing. And then you can try subtracting by an x from both sides, and the x's value is 2.24, so you can just subtract about 2.24 continuing. And then you have 99x, and you have 222, and now you can just divide by 99 from both sides. And you have x is 222 over 99, and if you simplify that, you'll get 2 and 8 over 33. That's your answer. What is the value of absolute value negative 25 plus 13 close absolute value? So simple thing, when the absolute value, inside the absolute value, you would operate it as it is. So if you subtract minus 25 plus 13, you would get negative 12. But because it's in the absolute value, the answer would come out to be a positive of 12. So the answer is just 12. What is the value of negative open absolute value minus a close absolute value? So you firstly want to figure out what is the value of a by operating this out. So you have an absolute value, so you would have negative, and this would be positive, so it would be just minus 3. And then you have the minus here, and then you have the absolute value here, and minus 12, it will become just a 12 of positive. So you have negative 3 minus 12, and you would get negative 15. And then you want to do this operation, that's the value they're asking for. So they say negative minus a, and a's value is negative 15, so a times negative 15. This would be positive 15, so you would just bring the positive 15 out, and it's going to be minus 15. So our value is just minus 15. Evaluate this problem. So take a moment and pause this question and try and see if you can get that. So if you do that, you would firstly do the insides of the absolute, so kind of treat it like a parenthesis. So 9 minus 5 is 4, plus 12 minus 17 is negative 5. You then bring out all the absolute values, so plus. So you can just simplify. So 4 plus 5 is 9 minus 5. That gives us 4, which is the answer we have right here. So to this question, you would need to remember PEMDAS. So for PEMDAS, you follow the rules of parentheses, exponents, multiplication, division, addition, and subtraction. That tells you the order of how to do the expression. So you want to start with parentheses. So parentheses is here. So 15 minus 5, you take out that would be 10. You take that out of the parentheses now. And then you do exponents. So you can do it at the same line. So 14 minus 4 is going to give us 10. And then do the exponent. So 2 to the third is 8. So now you have that out, and now it's multiplication and division that's going to be done next. So you do 10 divided by 8, and that's going to be 1.25, and then 10 times 2, which is going to be 20. So always remember you have to do multiplication and division before the addition and subtraction. So now you can add, and this is how you would get that answer. To simplify this expression, you again use PEMDAS. So you would firstly do what's inside the parentheses. So 15 minus 20, that's going to give us -5. And then you move on to the exponent. So you have the 2 to the second, and you would get that as a 4. And you can also multiply this in the same line. So 8 times -5 is going to be -40. And so since this has a brackets, it's also another form of parentheses. So you would do all of this first. And so now you can finish up what's inside the bracket. So -40 divided by 4 is just -10. And you can take that out. So now you have this expression. And now you would just simplify it by doing the subtraction. So you do, you can do 6 minus 10 minus 36, or you can do this part first. So you have -46. And 6 minus 46 is -40. So now you simplify this expression. So again, do what's inside the parentheses first and then the brackets. So inside the parentheses, you have all of this number. You take out by simplifying the signs. So plus and negative times, that gives you negative, and plus and negative, and the negative and negative, so that gives you plus. And to the third, now you can apply the third to all of these numbers, and you would get, you apply to the third to the 0.1, so you get 0.001, and now you have all of this inside, and now you would just simply operate. So you would do the subtraction and addition, and you would get -0.037, and then you have the 100 outside, so you can multiply that and just bring it to the right twice. So you have 3.7, and now you have -3.7, and because it's inside the absolute value, you get 3.7, and it just becomes positive. So the way you should have done this is 12 minus 3 is 9, 2 to the third is 8, do the division, that will give you 37. So the rule for continuing the sequence is multiply by A, then subtract by B, find the next two terms. So they told us a rule, so you multiply the number by A and then subtract it by B. So we wrote out the expression of the first problem. So we had 2 at first, and then you multiplied the 2 by A and you subtracted by B, and that gave us the 6 because they put 6 next. And we can try and write that expression for 6 and 22 as well. So we have 6A minus B, that's what gave us 22. So to find the terms, we can subtract the first equation from the second to give us a simplified version. And so we get 4A minus 16, and we got that by just subtracting 6A minus B equals 22. You subtract the whole thing, 4A minus B, 6. So we had 2A here, and the B cancels out, and 22 minus 6, that gives us 16. Well, this should have been a 4. So it's 4A minus 16. So 4A gives you 16A, and if you divide it by 4 from both sides, A gives you 4. So now we figured out what A is, and now you want to do the first expression. We use the first equation to figure out what B is. So you plug that in, so it's 2 times 4 now because the A is 4, minus B equals 6. So you multiply this, so you get 8 minus B equals 6, and then you want to isolate the B to get the value. So you can subtract the 8 from both sides. You'll get negative B equals to -8, and -2 because 6 minus 8 would be the -2. And so you have divided by negative from both sides, so you really just divide by -1, so you get B equals to 2. So the next two terms, we can figure that out by using by plugging in the value of A and B. So A is equal to 4 and B is equal to 2. So since we know the next terms is done by multiplying by a and then subtracting by b, we can do this. So we have 86 times 4 that give and minus by 2, that gives us 342, and 342 times 4 minus 2 will give us 1366, and that's how we get the next two terms. The sequence above continues according to the pattern shown. What is the sum of the first 50 terms of the sequence? So in this sequence, we have -3 to 5 as a repeating unit. So, and 15 divided by 3 is 16, remainder 2. So in the first 50 terms, there are 16 units of 3 to 5, and the last two terms are going to be -2 and 2, -3 and 2, because we know that's the first two terms that come in the repetition. So the sum of the first 50 terms can be written as this expression, -3 plus 2 plus 5 times 16 plus -3 plus 2. And we would get our, if you simplify, you would get our answer as 63. That is the sum of the first 50 terms. Take a moment and pause this video and try this question. So as you can see, this set has a repetition of 3, of 1, 2, 3. If the sequence above continues as shown, what is the sum of the first 66 terms? So since these are repeating in sets of 3, we divide 63 by 3, 66 by 3, and that gives us 22. So we know that, and there's no remainder, so we can simply just add 1 plus 2 plus 3 and multiply that by 22, and that will give us our answer. So 1 plus 2 plus 3 is 6 times 22. And that will give us 132, which is the answer right here. If it is now 5 a.m., what time was it 52 hours ago? So since -52 hours is going to be equal to -24, -24, -4 hours. So the time 52 hours ago is, if you subtract 5 a.m. minus 4 hours, that will give us 1 a.m. Because, as you know, one day has 24 hours. So 52 has two 24s in it. If you subtract it, it'll you have 24 twice, and then if you divide it by 24, you'll have 24 twice, and you'll have a remainder of 4 more hours. So that means 2 days ago it was 5 a.m. exactly, and then if you subtract 4 more hours, you'll get 1 a.m. On the number line, what number is halfway between 0.3 and 0.9? So the midpoint of 0.3 and 0.9 would be decided if you add 0.3 plus 0.9 and then divide it by 2. So if you add that, you get 1.2, and if you divide it, you get 0.6. Because if you think about it, you have, so our answer is 0.6. On the number line above, AB is equal to 2 and 1/2, AD is 5 and 5 over 6, CD is 1 and 2 over 3. What is the position of C? So we have this information. So we have AB is equal to 2 and 1/2. So we can figure out A by taking what they gave us for B, and they told us B is 2 and 1/3, and subtracting that with the value of AB of length. So we can figure out A by subtracting B minus the value of AB, the length. So we subtracted that, and since these are mixed numbers, we make this into improper, then find the common denominator, and we got the answer of -1/6. So we know now the value of A. So now we can figure out the value of D as well, because they give us AD is equal to 5 and 5/6. So what we can do is, since we have A, which is over here, A plus the value of AD will give us the position of D. So if you do that, we add -1/6 plus 5 and 5/6. You add that same way, and you get the answer of 5 and 2/3, which is now the position of D. And now we want to figure out the position of C, so we use the other information that we have. CD is equal to 1 2/3. So we can figure the position of C by taking the position of D and subtracting it from the value of CD. So we have 5 4/6, which is the same thing as 5 2/3. You subtract that and you can simplify it and do the same way you do the subtraction problem, and you get 24/6, which is a value of 4. So that tells us the position of C is actually 4. So that's our answer right there. So take a moment and pause this video and try this question. This question says, on the number line shown above, AB is equal to 1/10th unit. Point P is located 7/30th unit left from point B. What is the value of P? So to do this question, we would firstly have to figure out the position of B, and then we can find what is the value of P. So we know the length of AB is 1/10th, so we can add 3 and 3/15th plus 1/10th, and that would tell us the position of B. And if you do this, you should have gotten So you would get 3 and 29/30th. So that is the position of B. So now, since we know that P is located on 7/30th, the left of point B, so we would take the value, the point, position point that we know that is of B, and subtract 7/30. So if you subtract the tops, you would get 22/30. So that would be 3 and 22/30. And if you simplify this, you would get 3 and 11/15, which is the answer right here. So download the SHSAT Prep app for iOS or Android for more practice. This is the end of lesson 5.